To conclude with this second example of general economic equilibrium, I simply note two points. First, the solution we obtain in a pure competition economy, in the equilibrium of a pure competition economy, is the same which we obtain in the case of an individual which is totally isolated. For example, Robinson Crusoe on the island, on the desert island. Remember a very well-known novel by Defoe. The subject is on a desert island and must employ his time in order to produce some good, for example, fish, and to use the time for other tasks, for example, to build a home for himself. The situation of this subject would be the following. This is the production function of a consumption good. He has a total time like this. He could employ all the time in order to produce good, and in this case he would obtain a maximum quantity of consumption good. He can use all the time as leisure, and in this case he does not obtain any quantity of good on some intermediate situation, a repartition of the time between leisure and labor. What is the optimal solution? The point which belongs to the highest indifference curve of Robinson Crusoe. He chooses the point on this production function which lies on the highest indifference curve. Note the total similarity of this result with these. You obtain substantially the same result of a competitive economy, provided obviously that Robinson has the same preferences of our worker. But note that the result, if the map of the different schools is the same, is also the same. So, a pure competition economy reproduces the same result of our isolated fellow on the desert island. And you can also compute in this case the so-called shadow prices which are implicit in this optimal point. And these shadow prices are simply the prices which would prevail in a pure competition economy with the same production function and the same structure of preferences. But they are not observable on the desert island, of course. They are observable only in the pure competition economy. However, note that also in this case, some property of convexity is necessary in order to have an equilibrium. Because if, for example, the function were not of this form, for example, because there are increasing returns to scale, you remember, it is impossible for a firm to maximize profit in a pure competition context when there are increasing returns. In this case, you would have, for example, a production function like this. In this case, clearly, as Salvador told you, it is impossible to maximize profit. Note, however, this is a very interesting result, that our Robinson Crusoe, which has a total time like this, could maximize his utility in a point like this. For him, non-convexity is irrelevant. He observed, this is the set of my possible pairs between Q and H. I choose the point which belongs to the highest indifference school. So, note that in the isolated economy, a solution always exists, provided that the functions are continuous and so on. While in an economy, in decentralized economy, a pure competition economy, if the properties of convexity, both of preferences and of production sets, are not verified, equilibrium may not exist. So there is a difference which shows the extreme importance of convexity properties in order to prove the existence of equilibrium. As we will show in the following part of the course, when we shall examine one after the other all the proof of existence of equilibrium. But let us stop here.